The Roer River, Germany. December 1944. Temperature hovering just above freezing. German machine gunners watch from concealed positions on the eastern bank, fingers resting on triggers. They've blown every bridge for 20 miles. The river churns dark and swollen with winter melt, 40 feet across and deep enough to swallow a Sherman tank whole. Natural barriers like this have stopped armies since the dawn of warfare. The Germans know it. They've studied their history. Rivers buy time. Rivers force delays. Rivers give defenders the advantage. They settle in to wait, expecting the usual. Days of Allied reconnaissance, pontoon attempts that would be sitting ducks, maybe a week before any serious crossing attempt. Time to reinforce. Time to dig deeper. Time to make the Americans pay for every foot of ground. Then, at no 600 hours, something impossible begins. Through the morning mist, trucks appear. Not just a few, dozens. They don't stop at the riverbank to unload boats or pontoons. Instead, men jump out carrying what looks like oversized steel puzzle pieces. The Germans squint through their scopes, confused. Before they can fully process what they're seeing, the first sections are already being assembled. Within 6 hours, Allied tanks are rolling across a fully functional bridge. The German officers receiving these reports refuse to believe them. Bridge construction takes days, sometimes weeks. That's not battlefield rumor. That's engineering reality. But the scouts aren't lying. The Americans aren't using traditional engineering. They're using something the Wehrmacht has never encountered. They're using Bailey bridges. And they're about to change warfare forever. The story begins not in the chaos of war, but in the methodical mind of one British civil engineer who understood a fundamental truth. In modern warfare, mobility is survival. Sir Donald Bailey wasn't a soldier. He was a quiet, unassuming employee of the British War Office, working in a department most people had never heard of. While tanks and aircraft grabbed headlines, Bailey focused on a problem that seemed almost mundane by comparison. How do you move an army when the enemy has destroyed every bridge? Traditional military bridges were engineering marvels and engineering nightmares. They required specialized equipment, skilled labor, precise measurements, and most critically, time. Lots of time. Building a standard military bridge might take a week or more, assuming you weren't being shot at. Factor in enemy fire, and the timeline stretched indefinitely. Bailey looked at this problem from a different angle. What if you didn't build a bridge at all? What if you assembled one? In 1940, working in his home workshop, Bailey designed something revolutionary, a bridge made entirely of interchangeable panels, each weighing just 570 pounds, light enough for 6 men to carry, simple enough to assemble without special training, strong enough to hold a 40-ton tank. The panels measured 10 feet long and 5 feet high, with pin connections that required no bolts, no welding, no specialized tools, just panels, pins, and manpower. The genius was in the simplicity. Every piece was identical. Every connection was the same. A soldier who learned to assemble one section could assemble 100. The British Army tested the first Bailey Bridge in 1941. Engineers assembled a 30-foot span in under 2 hours, without blueprints, without heavy equipment, just men, panels, and pins. Field Marshal Bernard Montgomery examined the design personally. He walked across the test bridge, studying every joint, every connection. Then he did something unusual for a man known for his reserve. He smiled. "This," Montgomery said, "is the best thing in this war." He wasn't exaggerating. By 1944, as Allied forces pushed into Northwest Europe, the Bailey Bridge had evolved from experimental equipment to standard issue. But knowing how to build them in training camps and building them under fire were entirely different propositions. The Germans understood bridge warfare better than almost anyone. Their own engineers were superb, their demolition teams ruthless. As the Wehrmacht retreated across France, Belgium, and into Germany itself, they followed a scorched earth policy with Germanic efficiency. Every bridge they crossed, they destroyed. Every river became a potential killing ground. They'd seen this strategy work before. In Italy, a single blown bridge at the Rapido River had stalled the Allies for months, costing thousands of casualties. Rivers were force multipliers. You didn't need massive armies to defend them, just good positions and patience. Let the enemy exhaust themselves trying to cross, then counterattack when they're most vulnerable. The German defensive doctrine was sound. It had worked for centuries. It should have worked in 1944, but it didn't account for the Bailey Bridge. More precisely, it didn't account for the men who built them. Allied combat engineers weren't regular infantry. They were specialists, but not in the way most people imagine specialists. These were farm boys from Iowa who could fix a tractor blindfolded, city kids from Detroit who'd worked construction since they were 14, miners from Pennsylvania who understood structural integrity instinctively. The U.S. Army's combat engineer battalions and the British Royal Engineers had spent months training with Bailey bridges. They'd practiced in rain, in darkness, under simulated fire. They'd learned to assemble panels while wearing gas masks. They'd timed themselves obsessively, shaving minutes off their records, competing between squads to see who could build fastest. What they were really learning was something deeper than bridge construction. They were learning to function in chaos. The Roer River crossing in December 1944 wasn't the first time Allied engineers had shocked German defenders, but it was one of the most dramatic demonstrations of what combat engineers could accomplish. The 291st Engineer Combat Battalion drew the assignment. They'd already built 14 bridges across France and Belgium. They'd worked under artillery fire, mortar attacks, and sniper harassment. They'd lost men. They'd kept building. Their commander, Colonel David Pergrin, was 27 years old and looked younger. He'd grown up in Pennsylvania, studied civil engineering at Penn State, and joined the Army in 1941 with no illusions about war's romance. He understood numbers, logistics, and a brutal truth about military engineering. Speed saved lives. Every hour we don't have a bridge across is another hour our boys are stuck on this side, Pergrin told his officers the night before the Roer crossing. The Germans know where we are. They're targeting this position right now. The faster we build, the faster everyone moves, the fewer casualties we take. Speed isn't just efficiency, it's survival. His men understood. They'd already proven it repeatedly. At 600 hours, with morning mist still hanging over the river, the first trucks rolled to the riverbank. German observers watched, reporting back to their command posts. The Americans were attempting something at first light. Standard procedure would be reconnaissance, then preparation, then actual bridge construction starting perhaps the next day. The Germans were calculating in terms of days. The Americans were calculating in terms of hours. The 291st had practiced this specific crossing. They'd found a similar river back in England and timed themselves. They knew the Roer was 42 feet across at this point. They needed 14 panels. With 3 squads working simultaneously, they estimated 6 hours from first panel to tank crossing. Corporal Mike Chinchar, a coal miner's son from Scranton, led the first assembly team. He'd built 17 Bailey bridges. He could identify a bent pin by touch in complete darkness. His hands were scarred from 100 small injuries, crushed fingers, metal cuts, burns from welding repairs. He never wore gloves, even in December. Said he needed to feel the connections. "Panel 1, he shouted over the engine noise. 6 men lifted the first 10-foot section, 570 pounds distributed among them. Not impossible, but not easy, especially with rifles slung across their backs and helmets throwing off their balance. They moved in synchronized steps, a choreography learned through repetition. The panel slid into position on the launching nose, a temporary extension that would allow them to build outward over the water without falling in. Pin connections clicked into place. Chinchar ran his hands along each joint, checking by touch as much as sight. "Panel 2. The German machine gunners were still watching, trying to understand what they were seeing. This wasn't pontoon construction. This wasn't any bridge-building technique they'd been trained to recognize. The Americans were assembling something from prefabricated pieces, but at a speed that seemed impossible. At 0637 hours, the first German mortar round landed 30 yards from the bridge side. The explosion sent mud and water spraying across the engineers. No one stopped working. They'd been trained for this, expected it. The German gunners were ranging in, walking their fire closer. Standard harassment protocol. Make the engineers take cover, slow them down, force delays. Chinchar didn't even look up. "Panel 3. More mortar rounds, closer now. 20 yards, then 15. Shrapnel whistled through the air. One engineer, Private James Delano from Boston, took a piece of metal through his shoulder. He grunted, staggered, kept holding his corner of the panel until it was secured, then walked to the aid station. Panel 4. By 0700 hours, the bridge extended 15 feet over the river. German machine gun fire began probing the position. Tracers skipped across the water. The engineers had prepared for this too. Smoke generators activated, pumping thick white clouds across the riverbank. The smoke didn't stop the bullets, but it made accurate fire nearly impossible. Behind the smoke screen, Chinchar's team moved like factory workers on an assembly line. They'd done this so many times that words became unnecessary. A gesture, a nod, and 6 men moved as one. Panel after panel after panel. The beauty of the Bailey design revealed itself under these conditions. If a panel got damaged, bent by shrapnel, or cracked by a near miss, they simply grabbed another one. Every piece was identical. Every piece was interchangeable. Damaged section, remove it, slide in a fresh one, keep building. Traditional bridge construction required precision. Custom fits, careful measurements. The Bailey Bridge required only determination. German Lieutenant Klaus Richter watched from his observation post on the eastern bank, binoculars pressed to his eyes, trying to make sense of what he was seeing through the smoke. He'd been an engineering student at Berlin Technical University before the war. He understood bridge construction. He'd helped build military bridges in Poland and France. He knew the timeline for this type of operation. What the Americans were doing was impossible. "How long?" his commanding officer asked over the radio. Richter checked his watch. Not quite 2 hours since the first American truck arrived. Through gaps in the smoke, he could see the bridge extending across the river, a third of the way across already. "They've made significant progress," Richter reported, choosing his words carefully. "More than expected." "How much more?" "Sir, if they maintain this pace..." Richter did the math in his head, double-checked it, couldn't believe his own calculations. They could have vehicles crossing by early afternoon. Silence on the radio. Then, "That's impossible, Lieutenant. Double-check your observations." But Richter's observations were correct. By 1000 hours, the bridge was halfway across the Roer. By 1130 hours, 3/4. The German mortars continued firing, but the Americans had positioned anti-aircraft guns to suppress the German positions. Smoke generators kept the bridge shrouded. Engineers rotated in and out. fresh teams replacing exhausted ones, but the work never stopped. Never stopped. Corporal Chinchar's hands were bleeding. He'd lost track of how many panels they'd installed. His team had been working for 5 straight hours with minimal breaks. His arms felt like lead. His back screamed. Every breath was visible in the cold December air. "Last panel," someone shouted. The final section slid into place, pins driven home. Chinchar personally checked every connection on the last span. His bloodied fingers traced each joint, testing for any weakness. The bridge needed to hold 40-ton Shermans. There was no margin for error. At 12:04 hours, 6 hours and 4 minutes after the first panel touched ground, a combat engineer lieutenant walked onto the bridge, crossed to the far side, and waved the all-clear signal. 5 minutes later, the first Sherman tank rolled across the Roer River. Then another, then another. An entire armored company moving east into Germany while German defenders scrambled to reposition. The natural barrier they'd counted on to buy them days had bought them hours. Lieutenant Richter watched the American tanks cross, still struggling to process what he'd witnessed. In his engineering courses, they'd studied bridge construction as a time-intensive operation requiring specialized equipment and skilled labor. What he'd just seen violated every principle he'd been taught. He wasn't alone in his shock. German after-action reports from late 1944 and early 1945 repeatedly mention Allied bridge-building capabilities with something approaching disbelief. Words like unnatural and impossible appear in official documents. One German general wrote that the Allies seemed to conjure bridges from thin air. They weren't conjuring, they were engineering, but engineering of a type the Wehrmacht had never encountered. The Bailey Bridge's impact on World War II cannot be overstated. By the end of the war, Allied forces had built over 700 bridges across Europe using Bailey's design. They spanned everything from small streams to major rivers. The longest Bailey Bridge stretched 1,000 feet across the Rhine. General Dwight Eisenhower called the Bailey Bridge one of the 3 most important technological developments of the war, alongside the atomic bomb and radar. That assessment wasn't hyperbole. The atomic bomb ended the war. Radar won the Battle of Britain. But the Bailey Bridge won the ground war in Europe. Consider the mathematics of mobility. In World War I, advancing armies moved at roughly 3 miles per day, often less. Natural barriers, rivers, ravines, destroyed infrastructure, caused delays measured in weeks. In World War II, Allied armies in Northwest Europe sometimes advanced 30 miles per day. That tenfold increase in mobility wasn't just about better tanks or air superiority. It was about never stopping. The Germans could blow every bridge in France. It didn't matter. Allied engineers would have a new one up in hours. Retreat behind a river? American armor would be across before the Wehrmacht could establish defensive positions. The traditional defensive value of natural barriers evaporated. Some military historians argue the Bailey Bridge shortened the war in Europe by months, maybe longer. Every river crossing that took 6 hours instead of 6 days was time the Germans didn't have to regroup, reinforce, or prepare defenses. The relentless pace of the Allied advance gave the Wehrmacht no breathing room, no opportunity to stabilize lines. But the bridge's legacy extends far beyond World War II. The basic Bailey design, with minor modifications, remains in use today. The U.S. military still deploys Bailey-type bridges. After natural disasters, earthquakes, floods, hurricanes, Bailey bridges appear within hours to restore vital connections. The same principles Donald Bailey sketched in his home workshop in 1940 are saving lives in 2024. Corporal Mike Chinchar survived the war. He returned to Scranton, went back to the coal mines, rarely talked about his service. When his grandchildren asked what he did in the war, he'd shrug and say he built bridges. That was technically accurate, but wildly insufficient. He and thousands of men like him had revolutionized warfare by making the impossible routine. They'd turned rivers from barriers into minor inconveniences. They'd proved that the right tool, in skilled hands, under impossible conditions, could change the course of history. The 291st Engineer Combat Battalion built 62 bridges during their time in Europe. They lost 28 men doing it. Every one of those bridges enabled advances that saved countless other lives. Every hour they shaved off construction time was an hour American infantry didn't spend pinned down in kill zones. Their work wasn't glamorous. Nobody makes movies about combat engineers assembling prefabricated panels under mortar fire. No monuments celebrate the men who built bridges while machine gun bullets split the air around them. But their contribution to victory was as essential as any tank commander or fighter pilot. The Germans learned this lesson the hard way. By early 1945, German defensive planning simply stopped relying on rivers as significant barriers. Allied engineers had demonstrated too many times that they could cross anything, anywhere, anytime. The tactical doctrine that had worked for centuries became obsolete in months. That's the true shock the German soldiers experienced. Not just surprise at Allied speed, but the dawning realization that fundamental assumptions about warfare had changed. The rules they'd learned, the strategies that had always worked, suddenly didn't matter. Donald Bailey's simple idea, interchangeable panels instead of custom construction, had rewritten the rules of military engineering. His panels weren't just strong and light. They were revolutionary because they acknowledged that war doesn't allow time for perfection. Speed matters more than elegance. Function matters more than form. 6 hours to cross a river. That's what shocked the Germans. But the real story isn't about speed. It's about what speed enabled. It's about mobility as a weapon. It's about understanding that sometimes the best way to win a fight is to never stop moving. The Roer River crossing was one battle, one bridge, 6 hours on a cold December day. But those 6 hours represented thousands of hours of training, decades of engineering thought, and a fundamental reimagining of what was possible under fire. When German machine gunners watched American tanks rolling across that bridge at 12:09 hours on December 16, 1944, they weren't just watching a river crossing, they were watching their defensive strategy become obsolete in real time. They were learning that natural barriers only work if your enemy doesn't have combat engineers carrying 570-pound panels and the determination to assemble them under any conditions. The Bailey Bridge didn't win World War II alone, but it gave the Allies something priceless: time. Time to maintain momentum, time to prevent German regrouping, time to keep pressure constant and unrelenting, and in war, time is everything. The next time you cross a bridge, any bridge, take a moment to appreciate the engineering. Think about the calculations, the load-bearing specifications, the careful planning required. Then imagine building that bridge while someone is actively trying to kill you. Imagine assembling it from prefabricated pieces in 6 hours while mortar rounds explode around you and machine gun fire tears through the air. That's what combat engineers did repeatedly across an entire continent. They turned the impossible into the routine. They made speed sacred. They understood that every hour counted, that delays cost lives, that sometimes the most important weapon in a war isn't a gun at all. It's a 570-pound steel panel and 6 men determined to get it in place before the enemy adjusts their aim. The Germans were shocked by how fast the Allies built bridges, but the real story is deeper than shock. It's about innovation under pressure. It's about turning a civil engineer's sketch into a tool that changed warfare. It's about ordinary men doing extraordinary things because the alternative was unacceptable. Sir Donald Bailey died in 1985, having lived to see his design used in dozens of conflicts and disasters. His obituaries mentioned his knighthood and his contributions to engineering. But the real memorial to Donald Bailey isn't in any cemetery or monument. It's every bridge built under fire, every river crossed in hours instead of days, every advance that couldn't be stopped because combat engineers wouldn't let geography be destiny. That's the legacy. That's what shocked the Germans and changed history. 6 hours to cross a river, 6 hours to change everything.